So for our investigation of special right triangles, you should have filled in or been able to fill in the measurements for BC, AC, and the measures of all three angles. So to find the measures of BC, all we're going to do is count across. AC, we're just counting down. There's just 6 spots in between. And then when you see that you've got these two perpendicular lines here, we know that this is going to be a right angle, right? So we know this is 90 degrees. And we've learned earlier in our previous units that isosceles triangles, right, have two legs that are congruent, and that means that the angles across from them are also congruent. So if this is 90 degrees, and these two sides are 6 and 6, we know that the angles here have to match. They have to be congruent, so they're both going to be 45 degrees. Okay? So now that we know that, we can use Pythagorean theorem to solve for AB, because we can't just count that. We have to use that Pythagorean theorem. And the instructions say to simplify any radicals. All right, so let's keep that in mind as we go through. So I'm going to go ahead and switch colors here, and we'll do Pythagorean theorem to find the length of our hypotenuse. So we'll use, again, these are our two legs. A squared plus B squared equals C squared is my Pythagorean theorem. I'll write that over here so we don't forget. And now we're going to do 6 squared plus 6 squared equals x squared. That's what we're looking for. So 6 squared and 6 squared, that's 36 plus 36 equals x squared. If we add those together, I believe that's 72. 36 plus 36, yeah, equals 72. And we want to get the square root of that on both sides. So when we take the square root of 72, it doesn't come out to a nice pretty number. So we're actually going to use our factor ladder to simplify that. So I'm going to do that right over here. If we take 72 and divide by our prime numbers, I can divide by 2. Oh, I'm probably going to run out of room. 72 divided by 2 is 36. Divided by 2 is 18. Divided by 2 is 9. Divided by 3 is 3. Divided by 3 is 1. Okay, so now I would list all of those out underneath my radical. I would have 3 2's and 2 3's that are all factors, they're all getting multiplied. And I'm going to look for 2 of a kind. So if you notice, I have a pair of 2 here, a pair of 2's here, and a pair of 3's here. So both of those are going to come outside the radical. I have a 2 times 3, and then inside the radical we have a 2 left over. So when we simplify that, we would have 6 radical 2. So that's my measure for side AB. 6 radical 2. Okay, and we can do the same thing over here for number 2. I'm going to kind of run out of room a little bit. Let me draw a little line here. So for number 2, we had a side of 4 and a side of 4, and we're trying to find the length of the hypotenuse. So again, it would be 4 squared plus 4 squared equals x squared. So that's 16 plus 16, which is 32. And then we take the square root of both sides. And again, we want to simplify this radical all the way. So I'll use my little factor ladder. 32 divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. Divided by 2 is 1. Ooh, lots of 2's. And we're going to list those all out underneath our radical. So let's see, I've got 5 2's under here. 1, 2, 3, 4, 5. And I'm looking for 2 of a kind. So I've got a pair of 2's there, a pair of 2's there, which means I'm going to take both of those out. And I'm left with radical 2 underneath. So my length, if I were to simplify that 2 times 2, my length of that hypotenuse is going to be 4 radical 2. So again, we can't just count. We can't count how far across these are, because look, when we count here, I have 1, 2, 3, 4. Well, this is not an equilateral triangle here, so that can't be right for the distance. And same thing here, 1, 2, 3, 4, 5, 6. That's not going to be right. It's not an equilateral triangle. So we can't just count across for diagonals, which is why you have to use Pythagorean theorem. However, you can also use a special shortcut. Okay, so if we were to find the hypotenuse for problem number 4. Let's try that. So again, we're going to move that back. 2 squared plus 2 squared equals x squared for the hypotenuse. So we get 4 plus 4 equals x squared. So when we add those together, we get 8. We take the square root and simplify that. So I'll do my factor ladder over here. 8 divided by 2 is 4, divided by 2 is 2, divided by 2 is 1. So we would list those all out underneath the radical. I have 3 2's and I'm looking for 2 of a kind. So I pull that out. So my x is really going to be equal to 2 radical 2. Okay, let's try number 5. See if you can pick up on this pattern here. So let's see, for number 5, I would have 3 squared plus 3 squared using Pythagorean theorem equals x squared, which means we'd have 9 plus 9 equals x squared. I add those together and get 18, and then take the square root. And again, it's not a perfect square, so I'm going to have to use my factor ladder. 18 divided by 2 is 9, divided by 3 is 3, divided by 3 is 1. When I put those all underneath my radical, and I look for my 2 of a kind, I've got a pair of 3's here that would come out. So I would have my hypotenuse would be 3 radical 2. All right, let's try number 6 over here. So for number 6, I would do 5 squared plus 5 squared equals x squared. That would give me 25 plus 25, which is 50. And then again, factor ladder. I'll try to do that real small over here. Hopefully you can see that. Yeah. All right. So 50 divided by 2 is 25. Divided by 5 is 5. Divided by 5 is 1. So if I list those out under my radical, I've got a 2 and a pair of 5's. So that's my 2 of a kind. And I'll write that outside. So my x is really equal to 5 radical 2. You see the pattern there? Do you see how for all of these, my legs were a number, and then the hypotenuse was the leg times radical 2. My leg was a 4, the hypotenuse was 4 radical 2. My leg was a 2, my hypotenuse is 2 radical 2. My legs are 3, the hypotenuse is 3 radical 2. My legs are 5, the hypotenuse is 5 radical 2. So there's a pattern here. So let's look at what's going to happen for number 7. So if number 7, if you notice again that the legs were just the 2, the hypotenuse was the 2 radical 2, I would multiply. So if I want to get from the hypotenuse back to the legs, all I have to do is divide by radical 2, which means that my legs here are just going to be 7. How easy is that? So just going from the hypotenuse to the legs, we divide by that radical 2, and we're left with 7. Same thing over here. If I divide by radical 2, what's really in front of this number here, or in front of this radical? That's really just a 1. So that means that if the hypotenuse is 1 radical 2, both of my legs that are congruent are going to be 1. For number 9, if my hypotenuse is 8 radical 2, that means my legs, which are the same, are just going to be 8. Again, because this is a 45, 45, 90, it's a special right triangle. There's that special pattern there. Okay, so once we get to the bottom here, okay, we have this special shortcut. It's anytime you're trying to find the hypotenuse, it's the leg times radical 2. Anytime you're going from the leg, or trying to get the leg, it's the hypotenuse divided by radical 2. So we can use that same shortcut again. So if I know this is 45, 45, 90, so I know that this side is 36, and this side is 36. To get to the hypotenuse, I just multiply by radical 2. So it would be 36 radical 2. And here for number 11, oh, this one's a little bit tricky. So this one I'm going to need to divide by my radical 2. So to get back here, I would have to do 20 divided by radical 2. But what ends up happening when we do that? If I try to divide by radical 2, we can't have a radical in the denominator. So what we're going to have to do here, I'm going to pause real quick and plug in my camera here so it doesn't die on me. But we're going to have to do here, there we go, is rationalize the denominator. So if you remember that back from our first lesson in this unit, that means we have to multiply the top and the bottom by radical 2. That's the only way we can do the inverse of that square root, is to multiply by itself. When we multiply straight across then, I would have 20 radical 2 over, when we multiply a radical by itself, remember we do the inverse, so it would just be over 2. So I would have 20 radical 2 over 2. The only thing left to do is simplify that. And this is one of the more complicated ones. So this would just be 20 divided by 2 would be 10. So we would have 10 radical 2 over 1, or you could just leave it like this. So this is 10 radical 2, and this is 10 radical 2. Okay, so those would be the legs for this one. Now again, this is a shortcut. If you want to use trig ratios every time, that is totally fine. You can do that for all of these special right triangles. Once we learn about those trig functions, you can do that. But for right now, this is just a shortcut we can use, and it can come in really handy. Again, you can use Pythagorean theorem for a lot of these, and that's fine too. This is just a shortcut, and if you remember it, it's really helpful to have later on.